Hello mathematicians, this is Ms. Backfish and I am here to walk you through polynomial long division. I wanted to start out with a problem here. It's asking me to divide the polynomial x cubed plus x squared minus 19x plus 5. Divide that all by the polynomial x plus 5. I did want to point out before we get into it a couple of things, and there are other things we're going to talk about as we go through, but I wanted to point out how the problem is written. It can be written this way. It could also be written like this with the division bar. All right. It could also be written as a fraction. It can be written as a fraction with or without parentheses. All of these, 1, 2, 3, and 4, those are 4 different ways to write the exact same problem. So on all of these, that's what you're being asked to do, is you're being asked to divide. And so we're going to go ahead and set it up like division, and we're going to set it up like long division. Now, again, before we get into this, I want to go ahead and give you a quick refresher on how long division works in general. Okay, so let's go back to regular long division you learned how to do in elementary school sometime, maybe middle, and think about how that works. It's not exactly the same, but it's similar enough that it's worth taking some lessons from. First thing I do here is I say, how many times does 5 go into 3? Well, it doesn't. So then I say, well, how many times does 5 go into 32? And the answer is it goes 6 times, and I put that 6 here. 6 times 5 is 30. And then I subtract. 32 minus 30 is 2. All right? Now, what I just did is something that happens over and over again. It's a cycle that we have started. So I'm going to do the exact same thing again after I get prepared for the next step, or I prepare for that next cycle, by bringing down this 8, because 5 doesn't go into 2. Okay, so then I do exactly the same thing again that I did the first time. How many times does 5 go into 28? The answer is 5, and I put that up here, and then I multiply. 5 times 5 equals 25, and then I subtract. Since 5 doesn't go into 3, I'm going to pull this 9 down and start the cycle all over again. 5 goes into 39 7 times. So 7 goes up here. 7 times 5 is 35, and 39 minus 35 is 4. This is my remainder, because 5 doesn't go into 4, and there's nothing else to bring down. So I just wanted to remind you of that for a couple of reasons. Even though polynomial long division is a little different, a few things are the same. One is that whole part where I say, how many times does 5 go into this? Or how many times does 5 go into this? We're going to phrase it a little differently for polynomials. But that's what we start by asking. The next thing is, I take whatever that number is and I multiply and put it up underneath here. That was the 6 times 5 goes here. I'm going to do something very similar with my polynomials. And then I subtract. It's always subtraction going down for long division. Okay? And then again, if I don't have enough on deck here, so to speak, to start the next cycle, I bring something down. So let's look at that and see how that looks with polynomials. All right, first of all, I'm going to set it up in that same way with what we call the dividend up underneath the division bar and what we call the divisor out here. You don't have to remember those right now. I'm going to show you a graphic or a written. It's not really a graphic of that in just a second. Okay, so I'm dividing this polynomial by x plus 5. So instead of saying how many times does x go into x cubed, because a lot of times we don't really know, we don't think of it the same way, we don't know how to answer that. We're still asking that same question, but we're going to say, what would I multiply this by to get this? What would I multiply x by to get x cubed? Well, this is x to the first. To get x cubed, I need to multiply by 2 more x's. So that's x squared. Okay? So I'm going to put x squared up here. And then notice that when I asked that question, I only asked it about the x. What do I have to multiply this first term by to get this? But now when I do the multiplication and put something here, I'm going to do it for both terms. In other words, x squared times x gives me x cubed. And x squared times 5 gives me 5x squared. Okay, so I found the x squared up here just by paying attention to only the first term. But once it's up there, I multiply times both of these things and put them under their respective buddies here. Okay? Then I'm going to subtract. When I subtract, x cubed minus x cubed gives me 0. So this basically kind of cancels out. That can be a way of remembering that subtraction is what happens here. It's not addition because x cubed plus x cubed would be 2x cubes. I want these to go away, so this is subtraction. This is 1x squared. 1x squared minus 5x squared. 1 minus 5 is negative 4. Now, if I have two terms here, then I need two terms here. I think of that as two terms on deck. So that means I need to bring down another term. And what I have just done is one cycle. I'm going to recreate that exact same cycle once again next. So again, I start with what do I multiply this by to get this? X times what equals negative 4x squared? Well, x is 1x, so to get 1 to be a negative 4, I have to multiply by negative 4. And to get x to be x squared, I have to multiply by x. So it's going to be negative 4x. So minus 4x goes up here. And then when I multiply and bring it down here, I do it for both terms. Negative 4x times x is negative 4x squared. Negative 4x times 5 is negative, I made a long 2, sorry, negative 20x. One thing to point out here, if I did not have the same thing, if I didn't get the same thing here that was right above it, that would tell me that I was wrong when I came up with what do I multiply this by to get this. All right, I have to have this times this should give me the same expression, the same monomial that I had here. Because when I get negative 4x times x and this, these line up, and negative 4x squared minus negative 4x squared is 0x squared. Those have to cancel out, or you have chosen the wrong thing to multiply by. Now I'm ready for the subtraction step again. Again, the subtraction makes no x squareds. Be careful with minuses in subtraction. This is negative, or negatives in subtraction, negative 19 minus negative 20. Negative 19 minus negative 20. Let's come over here and think about that. This is what I've got. When you do minus a negative, that's the same as plus. Okay? So negative 19 minus a negative 20 gives me positive 1x. You don't have to write the 1, but I'm doing it just to be clear. And again, two terms over here means I need two terms on deck to start the next cycle. So I'm going to go ahead and bring down the 5. And then I'm ready to start the next cycle. Okay, I'm going to experiment with a different color here. And the question is, what do I multiply 1x by to get 1x? Well, that's just 1. So, plus 1 goes up here. Oh, good, that is a good one. 1x, 1 times x gives me 1x. 1 times 5 gives me 5. When I subtract 1x minus 1x, no x's. 5 minus 5, no constants, no numbers. And so I have no remainder. So that tells me that my answer is complete right here. That x cubed plus x squared minus 19x plus 5, all of that divided by x plus 5 gives me x squared minus 4x plus 1. Just side note, if it is nice and clean like that, where you have no remainder, you can think of that as saying that I now know that this biggest polynomial we started with can be broken into the factors x plus 5 and x squared minus 4x plus 1. This times this should equal this. It's just like if I said, what's 6 divided by 3? Let's say 6 divided by 3. You would say it equals 2. Well, that's the same thing as 2 times 3 equals 6. So that's basically what we're doing here. If you divide the polynomial by another polynomial, whatever your result is, multiplied by what you were dividing by, gets you back to the original. Okay, let's come up with those terms again. I said I would mention those terms. This is an example on a different problem. All right, if I divide x squared minus 6x plus 3 by x minus 4, I get x minus 2 with a remainder of negative 5. Okay, so the thing here on top is my quotient. The original big polynomial, you might want to say, that you're dividing something else into, or taking something else out of, either way you want to look at it, that's your dividend. The divisor is the thing you're saying, I'm going to divide by this. I divide by the divisor. So the dividend gets divided by the divisor, and your answer is the quotient and possibly a remainder. Okay? So one way to write this that is very frequently requested if you get a remainder is that you say, okay, my dividend divided by the divisor, I'm going to write my answer as the quotient plus the remainder. Okay, let's talk about how that makes sense. If I divide 13 by 5, 13 divided by 5, 5 goes 2 times with 3 left over, and we put that as 5. So plus the remainder, and sorry I stated this poorly, over the divisor. So what I was trying to say here, and I'm sorry I misspoke. So dividend divided by divisor equals quotient plus remainder over divisor. When I say 13 divided by 5, my answer is not 2 plus 3. My answer is 2. This means the same thing as 2 plus 3 over 5. 2 is the quotient, plus it goes with a remainder of 3 over 5. Let's look at it this way. 2 times remainder 3. Okay, so 15 divided by 5 could be written as 2 plus 3 over 5. That's how we write that. That's what a mixed number is the quotient plus the remainder over divisor. So sometimes we do that with polynomials. Like for instance here, if you're asked to rewrite your answer that way, the way I would write this particular answer, let me move this other stuff out of the way, is I would say, okay, my answer for this problem is x minus 2 plus negative 5 over what I was dividing by, which is the divisor, x minus 4. So that's how I would express that answer. Because it's a negative here, you could write this as a minus. You could say x minus 2 minus 5 over x minus 4. That's another way to write the same thing. So let's do one that has a remainder and then write it that way when we're done. All right, new problem here. Okay, here we go. We are dividing the polynomial 2x cubed minus 3x squared plus 5x minus 1, dividing all of that by the binomial x plus 2. So I'm going to write it in the standard format here. And then I'm going to start my long division process. I start by asking, what do I multiply x by to get 2x cubed? X times 2x squared would give me 2x cubed. So 2x squared times x gives me 2x cubed. These match, so I obviously picked the right thing to multiply by. And then 2x squared times 2 is positive 4x squared. The next step is the subtraction. That basically makes this become 0. And you have to be very, very careful about your signs here. Negative 3 minus positive 4. Negative 3 minus positive 4 is negative 7. Then I need to bring down one more term because I'm dividing by 2 terms. I need to have 2 terms on deck. And I'm ready to do the same cycle again. So to do it again, I'm going to ask myself, what do I multiply x by to get negative 7x squared? You might want to pause the video and try to finish this problem on your own. All right, let's go ahead and finish it together. X times negative 7x would give me negative 7 x squared. So negative 7x times x is negative 7x squared. Negative 7x times 2 gives me negative 14x. Now I'm ready to subtract. These go away because it makes a 0, 0x squared. And then 5 minus a negative. Minus a negative becomes plus. So 5 minus a negative 14 is 5 plus 14 is 19x. And again, I will bring down another term so that I have two terms on deck. Next step, this times what gives me 19x. Again, feel free to pause the video and finish the problem on your own. We're doing the exact same cycle we've done twice now. I'm going to do a different color. X times 19 is going to give me 19x. So 19 times x is 19x. 19 times 2 is 38. Then I'm going to subtract. This gives me 0 x's. Negative 1 minus 38 is minus or negative 39. That's my remainder. So I'm done, and I can rewrite my answer as the quotient plus this remainder over the divisor. I'm going to go ahead and write that up here. Plus negative 39 over x plus 2. That's my answer. Okay, one thing I want to point out here, because this becomes crucial in certain problems. Notice that everything lines up vertically. Okay, not on top here, but looking here, underneath the division bar. Everything lines up vertically in terms of like terms. We can only add and subtract like terms. So we have everything that we're adding and subtracting are alike terms. So all of the x cubes are vertically on top of each other. They're in a column. All of the x squareds are in a column. All of the x to the first power are in a column. All of the constants, or just plain numbers, are in a column. That's really important. And what that means is that if I didn't, in my original problem, what if this hadn't been there? What if it had just been 2x cubed plus 5x minus 1? What if this wasn't there? I would have to put a placeholder in that spot, or else I wouldn't have a place for all of the other x squareds to go. And I'll show you that on the next problem. One other thing I want to point out here, sometimes teachers teach this a little bit differently. They take this subtraction that we do on each step and they say, instead of subtracting, let's change the sign and add. Same thing, so you're welcome to do that. Like I could say, I'm going to take this positive 4, I'm going to change it to a negative 4 and then add. Well, you get the same thing. So subtracting by a number is the same as adding its opposite. So if your teacher tells you to do it that way, that's not different from what I'm doing. It's just a different way of saying the exact same thing. So I just wanted you to know that. Okay, so here's our last example, and this speaks to what I was just talking about a second ago. Is notice the degree of my polynomial, my dividend, the big one I'm dividing other things out of, the degree of that top polynomial is 3, meaning the biggest exponent is 3. All right, so that means I need to have an x to the third, and then I need to have an x squared, an x to the first, and an x to the 0. In other words, I have to step down from there. I have to have each power less than that. When I write underneath the division bar here, I have to have a place for each power of x. So when I write this, I have to notice that I've skipped x squared. There's not an x squared term. So I write plus 0x squared. I have to literally write plus 0 times x squared in order to hold that place so that, like in the other problem we were just looking at, I misplaced it for a second there. Everything lines up. We have a column for the x cubes, we have a column for the x squareds, we have a column for the x to the first, and we have a column for the numbers, which is x to the 0. All right, so we got to make sure we do that here. And so that's why we put 0x squared. Notice this is something you have to do whether you're doing long division or its cousin, synthetic division. You still have to put a placeholder if you have no term for a certain power of x that is smaller than your degree. All right, so we're going to divide this by 2x minus 3. Great time to pause your video and try it yourself now that you have made sure to put that 0x squared placeholder in. Okay, let's do it together. 2x times what makes 4x cubed? Well, that would be 2x squared. 2x squared times 2x is 4x cubed. 2x squared times negative 3 is negative 6x squared. If we hadn't had this placeholder there, that would have been up under here, and we can't add unlike terms. We have to have the same exact exponent to be able to add or subtract our terms. So you have 0 minus a negative 6. Minus a negative 6 is the same as plus 6, so this is plus 6x squared. Bring down the next term. Again, 2x times what makes this? Well, that's going to be 3x. 3x times 2x gives me 6x squared. 3x times negative 3 gives me negative 9x. And then I subtract. Negative 7 minus a negative 9x is negative 7 plus 9x, or 2x. Then I'm going to bring down the 3. 2x squared minus, 2x minus 3. 2x times what makes 2x? Well, that's just 1. 1 times 2x is 2x. 1 times negative 3 is negative 3. And again, I subtract. 3 minus a negative 3 is 3 plus 3, which is 6. So there's my remainder. So my answer is going to be the quotient 2x squared plus 3x plus 1. And I have with a remainder of 6, which means plus 6 over the divisor. And that's my answer. And the most common way of writing it. Your teacher may prefer that you do something like this. Say that you have a remainder of 6 in a different way. That's fine. Make sure you do it however you've been asked to. Hope this has helped. And if you need to learn synthetic division, I'm about to make a video on that, so you might want to pop on over to see that one. See you soon.